Tonight, telescopes picked up a new light source in the sky. It appeared only hours ago, but the scariest part is not the light. The first thing to hit Earth is invisible. It passes through your body, through the entire planet, as almost nothing can stop it. And that means that between now and dawn, the sky is about to change state. Stay to the end of this video, because it does not arrive as one event. It arrives in 3 layers: an invisible warning, a thinning ozone shield, and a delayed odor that can last for years. The cruel part is that everything can look normal, until you realize it already started. Here's the good news. Earth is not sitting in the eye of the storm of the Milky Way. Our solar system is inside the local bubble, a region of unusually thin gas like a cleared-out cavity carved by ancient stellar explosions. But safer does not mean immortal. The irony is that those very explosions scattered the heavy elements across the galaxy: gold, uranium, the raw material of planets. In plain terms, the stuff that built Earth came from stars dying. The problem is this: if a new explosion happens close enough, the first thing it hits is not the ground, it hits the atmosphere. In space, close is not a feeling, it is a number. Within about 50 light years, the risk to the biosphere starts rising sharply, not because the blast physically blows Earth apart, but because radiation and high-energy particles can rewrite the chemistry of the atmosphere. Around 30 light years, it can become a civilization-level crisis. And even farther out, around 150 light years, you can still get long-term biological effects. In this video, we are going to assume the bad scenario: a supernova at roughly 25 to 30 light years away. It may not erase life instantly, but it can turn Earth into a place where life gets hit in layers. First the atmosphere, then ecosystems, then society. It does not kill you with one punch, it kills you with a chain reaction where every consequence feeds the next. Most of the time, a star survives through a fragile balance. Fusion pushes outward, gravity pulls inward. Fusion creates energy, energy creates pressure. Pressure holds the star up, but fuel is not infinite. In a massive star, as the main fuel runs low, the core compresses, heats up, and starts burning heavier and heavier elements until it makes iron. And iron is the end of the road. Iron does not give you energy, it consumes it. Now comes the terrifying part. Once the core becomes iron, things move so fast you do not have time to believe or doubt. When the core turns iron, the star loses its pressure support. Gravity wins, the core collapses in seconds. In that collapse, electrons get forced into protons, creating neutrons and releasing a flood of nearly invisible particles, neutrinos. The core shrinks from something the size of a city down to about 30 kilometers. A neutron star is born. Neutrinos escape almost immediately. But the light has to wait. A shockwave has to fight its way out through the star's outer layers before anything bright reaches space. So Earth can receive the warning before we ever see the explosion, sometimes hours in advance. And that moment is surreal. You look up and see nothing unusual. But instruments are telling you the universe just pulled the trigger. Observatories notice the spike first, a sudden surge in neutrino flux. If it is coming from a nearby star, it is the signature of a core collapse in progress. And in that short window, humanity has one job: point every telescope at the same coordinates and start counting down. No sound, no shockwave you can hear, just the feeling that the universe pressed start. Then, hour by hour, the new point of light appears and grows. By the first day, it is a star that was not there yesterday. By around 18 hours, entire cities stop and look up. By 48 hours, you can see it in daylight, a bright point pinned into the blue sky. By 72 hours, night stops being night. It becomes a permanent twilight. The moon brightens the whole sky. This is different. This is brightness from a single point. Like the sky has been pierced by a glowing needle. It is beautiful, and it feels wrong. And while people argue whether it is stunning or terrifying, something has already started hitting Earth from above. If you think the danger begins on the ground, you are looking in the wrong direction. The first strike lands in the stratosphere. That is why this disaster begins where you cannot see it. High-energy radiation slams into the upper atmosphere, especially the stratosphere, where our ozone shield lives. Ozone is Earth's UV filter. When that filter thins, ultraviolet radiation stops getting absorbed high above you. It reaches the surface like a kind of invisible rain. Week 1. Measurements show ozone dropping noticeably. Months 1 to 6. Background UV climbs. Sunny days stop being harmless. Auroras begin showing up at lower latitudes. They are gorgeous, but they are also a sign that the atmosphere is being heavily ionized. At the same time, photochemical reactions create NOx in the upper atmosphere, nitrogen oxides that act like a hazy chemical smear. From this point on, going outside is not just about the weather, it is about exposure, and the change becomes painfully ordinary. People start avoiding midday the way they avoid storms. Long sleeves, protective glasses, and face coverings become normal. The first to take the hit are the people who cannot opt out of sunlight. Kids, farmers, fishermen, outdoor workers. Then, after months to a year, the damage reaches what keeps us alive. On land, harvests start slipping. Higher UV stresses plants. Atmospheric chemistry shifts. The weather becomes harder to predict. But the most silent happens in the ocean. Phytoplankton are the grass of the sea. They absorb CO2, produce oxygen, and feed the entire marine food web. If phytoplankton collapse, the ocean's food chain snaps, and the ocean weakens like a lung with scar tissue. When ecosystems lose function, society loses its most important trait, resilience. At that point, the question is no longer, is the sky dangerous? The question becomes, can we still feed ourselves? And then comes the delayed hit, the one people dismiss because it does not arrive instantly. Cosmic rays. These are high-energy particles moving near the speed of light. When they slam into the atmosphere, they create showers of secondary particles and increase ionization in the air. Years 1 to 10, the atmosphere becomes more electrically active, lightning becomes more frequent, storm patterns intensify, chemical reactions increase the risk of acid rain, and then it stops feeling like an event and starts feeling like a loop. Stronger storms lead to more wildfires. Wildfires load the air with smoke and aerosols. Aerosols block sunlight and cool temperatures. Growing seasons shorten, food systems strain, societies weaken, damage increases. This is not a disaster that kills you with an explosion. It is a disaster that erodes the atmosphere, the biosphere, and human systems for years. As atmospheric damage persists, the effects stack on top of each other. On a 50 to 100-year timeline, the question is not, does radiation kill people? The question is whether food, energy, medicine, and infrastructure can survive repeated shocks. Civilization does not break because of one blast. It breaks because every year it loses a little more resilience, until there is no recovery left. But there is something even more ruthless than a supernova, a gamma-ray burst. A GRB does not radiate evenly. It fires energy in an ultra-narrow beam, and if Earth is in that beam, the UDER goes straight into the stratosphere, straight into the ozone layer. It does not need to be 25 light-years away. It just needs to be aimed at us. The good news is that the beam is narrow, so the odds are low. But the bad news is that if it hits, the consequences can arrive faster and be much harder to avoid. Centuries to a few thousand years later, what remains is an expanding nebula, a glowing scar in the sky. Beautiful, in a way that reminds you the universe is not only romantic, it is violent. And the final irony is this: those same explosions that can destroy life are the ones that created the ingredients for life. They forged heavy elements. They built worlds. They built us. The universe creates, and the universe erases. So here is the map of what you just heard. Neutrinos are the warning. Ozone is the shield. Cosmic rays are the long, grinding erosion. Now let me ask you something. If a new star appeared tonight, what is the very first thing you would do? Comment one sentence starting with "I would," and then choose your letter, N, O, or C. Neutrinos, ozone, or cosmic rays. Which one gives you the deepest chill, and why? And if you want a part 2 in the same cinematic style, subscribe so you do not miss the next one.